Hello and welcome to AHDB Pork Live. On this webinar, we're going to be covering the highly important area of cleaning and disinfection on farm. From my perspective, I think biosecurity remains one of the most undervalued aspects of farm management, but also one of the most important, as we shall find out today. Tonight, we have two presentations. The first is going to be given by Dr. Becky Gosling from APHA. She's a senior research scientist at that institution, and she will be looking at the efficacy of disinfectants in more detail. Following that, we have a talk from Jamie Robertson from Livestock Management Systems, and he will be giving an overview of clever cleaning. So what I'm going to do now is I will hand over to Becky to give the first presentation. Thank you very much, Becky.
Okay, thank you, Martin. As Martin said, I'm a research scientist at the Animal and Plant Health Agency, and my research at the moment focuses on the use of disinfectants in a farming environment. So disinfectants are used in a range of different situations on farms to control disease as a form of prevention, but also to address known disease problems. In the UK, DEFRA approves disinfectants at specific concentrations as being suitable for use against specific pathogens in the case of something like an outbreak. So you might have come across them as the DEFRA approvals, disinfection concentrations, which are often on the back of the different disinfectant containers. There are 5 different DEFRA approvals disinfectant orders, and they cover a range of different animals and different organisms. So there's the poultry disinfectant orders, tuberculosis, swine's vesicular disease, foot and mouth disease, and then the 5th one is what's referred to as general orders, and this covers everything else that isn't already covered in one of the previous orders. And when we're doing the testing to allow a product to be DEFRA approved under the general orders category, we use Salmonella as the test organism. In addition to that, at APHA, we also carry out a lot of research into the effectiveness of different disinfectants and trying to make sure that we're testing them in a situation that's replicable to the farm itself. So it kind of similar to how they'd actually be used on farm. And that's what I'm going to talk to you about today. So when we're doing our testing, we like to select a range of different products, ones that we know farmers tend to use on farms or ones that we know are developed for different farming situations. And they fall under a range of different chemical groups. So the chemical groups are here on the left, and then hopefully on the right you recognise some of the product names there. I've not listed everything, but it's just to kind of give you a taster of some of the more common ones that people do use on farms. So when we're testing these products, so we try and choose ones that we know farmers actually use, so then the findings we have are relevant, and we test them at the DEFRA recommended concentration. We tend to use the general orders. This is usually the stronger concentration that they're often recommended to be used at in the case of an outbreak. We also use half that recommended concentration and twice that recommended concentration, mainly so we can get a good overview of how well the different disinfectants work, and allows us to demonstrate if you're not using the disinfectant at the recommended concentration, then actually it's kind of not going to not be effective, and you're going to be wasting money by using a product that's not going to do what you want it to do. And the data I'm going to show you today is from a range of different animals. So we've been doing some work with cattle feces, with pigs, ducks, and there's a bit of data on chickens and turkeys as well. So we're trying to use farm realistic models, which I'll go through in a moment. And at the minute we're using mainly Salmonella, but we do use a bit of E. coli as well, the virus cytotoxigenic E. coli, which is more relevant to the cattle industry. So the different testing methods that we use, we have 4 main models. We have a fecal suspension model, so going down the route of a boot dip. If you're using a boot dip regularly and it's getting full of fecal material and muck from around the farm, will it still be able to kill bacteria, or does it just become a big soup of bacteria that's going to contaminate anything that goes through it? We look at product stability, so again related to boot dips. Once you make them up, how quickly do they lose their effectiveness once you keep adding muck to them as you go? We look at surface contamination, so how well will a disinfectant work if there's still muck in the shed when you apply it? And then we also look at biofilms. So if a biofilm's formed, will a disinfectant be able to get rid of it? So I'll go through each of the models separately and just give you a bit of data that we've generated so far within our labs, just sort of so you can see how some of the different products work. So the fecal suspension model, or the boot dip model, we prepare a boot dip at the DEFRA general orders concentration, and we use again at the half general orders concentration and twice general orders concentration, so we can see the variation between the different levels there. And then we add animal feces to that. So in the same way as if you're using a boot dip, it's getting muck added to it all the time. Then we add the different bacteria. So for most of the animals, we use Salmonella as the test bacteria. For the cattle, we've used the E. coli. We allow the disinfectant a certain contact time with the bacteria, and then we take an aliquot out and try and recover it. So we want to see, could the disinfectant kill that bacteria or not? And here is just an overview of the best products that were most effective at the general orders concentration. So all of the highlighted blocks under each animal show which product was the most effective. So across the board, in all 4 species that we tested, the chlorocreosol products were the ones that were performing the best. But as you'll see, there are other products that sit within under them categories as well that were actually effective. So the glutaraldehyde-formaldehyde combinations were working quite well. And there was a bit of variation between the different animal species. I should point out that we don't have a lot of data on the chicken disinfectant model, so although the chlorocreosol product was the best, then other products are probably working reasonably well, but we just don't have a lot of data on it. Then if we move over to the stability over time, so once you've made up a boot dip, how long does it stay effective for? So again, we prepared the disinfectants just at the general orders concentration, and then added either pig or cattle feces regularly over a 7-day period. So as if you're using the boot dip on a regular basis, you get that build-up of muck that's in there, and then seeing if it could still work. Again, the chlorocreosol products came out really well, but some of the other products were quite perfectly working really well as well. The ones that have got stars in, so the 2 chlorocreosol products, they were still working effectively after 7 days. So the boot dips had been made up and had feces added to them over a 7-day period, and they were still able to kill the bacteria after 7 days. So sort of from our point of view, that's kind of probably one of the top products out there for that situation. So that's from like a boot dip side. Obviously, the other main use for disinfectants is to clean a house. And we wanted to see how well disinfectants work if you tried to clean an area if you try to disinfect an area without cleaning it first, which is obviously not what's recommended to do, but we wanted to look at the worst case scenario. So we again used 3 different concentrations of the disinfectant, and we coated the wooden dowels that you can see in the top of the screen with fecal material with the bacteria in it. So giving the bacteria a really good chance to kind of to stick to the wooden dowels, to get sort of hidden away inside there, and then expose that to the disinfectant. So in the same way, if you've got a nice dried on crust in an animal house somewhere and you've not managed to get rid of it before you disinfect, can that disinfectant get through and kill the bacteria that's in there? So when we looked at the half general orders concentration, all of the products failed, which is kind of what we'd expect, but it's nice to sort of just to reiterate that if you're not using disinfectants at the right level, they're really, really not going to work very well. The table that's on the screen is products that were tested at general orders concentration, and the ones that are highlighted are the ones that were effective. So you see the glutaraldehyde based ones, so whether it's glutaraldehyde and quaternary ammonia compounds or the glutaraldehyde and formaldehyde, they were the products that were most effective in that situation. When we increased them to twice general orders, we were seeing more of the products were effective. So as you'd expect, if you're using twice as much disinfectant as recommended, then things are going to be able to kill the different bacteria, but obviously you're using twice as much disinfectant. And then if we move on to biofilms, so biofilms are quite a hot topic at the minute. They form it can form throughout the farm, but tend to sort of be around water lines, feed lines, surfaces with wet environments where the bacteria is sort of constantly being can constantly survive and just form nice little layers which end up protecting the bacteria and allow it to become quite resistant to a range of different disinfectants, sorry. So what we wanted to do was allow biofilms to form on a wooden surface and expose them to disinfectants to see how well the disinfectants worked. So we allowed the biofilms to form over a period of time, so from 3 days up to 25 days, and then expose them to disinfectant. And so the figures you can see here on the slide, each little diagram is a different product that was tested, and as you move across that diagram, the higher the dots, the more times the disinfectant was failing to kill the bacteria in the biofilm. So the ones that are circled the products are very, very effective. So there's a glutaraldehyde and formaldehyde product, which is product C, and one of the chlorocreosol products, product K, where the little dots stay at the bottom of the graph the whole time, and they were able to kill the bacteria quite happily. If you look at figure G, so the one above the chlorocreosol K, you'll see that the dots increase quite nicely as you go along. So the product was effective at killing the bacteria in the biofilm for the first couple of days, and then it started failing, and you see the dots rise. We also looked at the use of disinfectant against Campylobacter in broilers. Obviously, that's kind of relevant to the poultry side. So we did a similar model to the stability model, but we actually included a really short contact time of 1 minute. So what happens if you just put the bacteria in for 1 minute? Can the disinfectant kill it? So a nice short contact time. And this is just this table is just kind of to highlight. So after 1 minute, only the chlorocreosol products and one of the iodine products was able to kill the Campylobacter. Everything else failed. And then after 30 minutes contact time, as you'd expect, we're starting to see a lot more of the products being able to kill the Campylobacter. So I think this just highlights that obviously a really quick disinfectant that then gets washed off or runs away doesn't actually work as well as leaving a longer contact time. And then moving on from there, obviously another consideration in terms of with disinfectants, obviously using them at the right concentration with a nice long contact time, is also going to be the cost. So it's all well and good highlighting which products are the best, but if they're also really expensive, it's something that you have to kind of weigh up as to how they're going to be used in a farming environment. So this table shows how much it costs to make up 5 litres of a general orders concentration disinfectant. So whether you're using it as a boot dip or you're diluting it ready to disinfect a house with. You'll see there's quite a range of prices. There's quite a few that sit around the 40 to 50 pence for 5 litres mark. But there are some of them, especially in the chlorocreosol bracket, which were the ones that were performing best in the boot dip environment, which can peak at nearly £3 per 5 litre boot dip that you're making up. So it is a consideration depending on probably on why you're using the disinfectant. So if you're using a disinfectant to deal with a known problem, then you might actually want to be making sure that you're getting a top of the range disinfectant to treat a specific problem. Whereas if it's a maintaining general day-to-day biosecurity, you might be happier choosing a different product. Obviously, this is something to discuss with your vet or with somebody from the disinfectants team, either HPA or AHDB. They can advise you as well. Some companies, depending on your industry, will obviously give you guidance on which disinfectants they prefer you to use for various farming environments as well. So in conclusion, we've seen how well a product works depending on the environments it's used in. So this is an important consideration when you're choosing which disinfectant you're planning to use. The glutaraldehyde, formaldehyde or glutaraldehyde quaternary ammonia compounds were most effective for surface disinfection, but any muck that's left in the house is always going to be difficult to disinfect. So I think it just reiterates the need for really good cleaning prior to disinfection. The chlorocreosol products worked best in the boot dip model for all of the species that we tested. And all products were rarely effective when we used them at less than the recommended concentration. So not measuring accurately can, as well as being a waste of money, can obviously lead to disease persisting and just poor disinfection across the farm. Thank you very much.
Okay, thank you very much, Becky. I think that's really good overview and some really quite nifty research. We're just in the process now of switching over to hear from Jamie. So Jamie will be on next, and Jamie's going to give a more general overview on sort of the do's and don'ts, really. So handing over to Jamie.
That's lovely. Thank you very much, Martin, and good evening, everybody. For me, what's so positive about this subject matter is that the potential is great. In the agricultural community, we've got a brilliant variety of expertise here. We probably tend to speak up to the poultry sector, and a lot of expertise in there. And Becky's mentioned Campylobacter, which we're still pushing against. To the other end of the sector, where I think there's people are going through cleaning operations, but as Becky's pointed out, there are instances where that work, the time and money that people spend on these operations is probably ineffective and therefore not good for business and certainly not good for health. So anyway, we move on here. So I'm saying that the link between hygiene and health is obviously very direct. I think again, I see a number of things on farms across all the species where the job is made much more difficult for one of a number of reasons. I think the key requirement is time and space, which I'll come on to later on, but quite frequently people will find that their systems have failed because they haven't had enough time to do the job properly. That is quite often linked to the fact as well that maybe there's not enough space to do the job properly. So that's an area, time and money, which I think we can address better, and I think that producers, perhaps if they took a view of that, would find the job could be done better. The second thing, again, addresses something that the science side has known for quite a long time, but it can be very hard to do in practice, is we need removal of organic matter. So really part of a proper cleaning operation should be, have we done the step where really we can't see a whole load of debris, organic debris lying around before we apply a disinfectant. Otherwise, the disinfectant doesn't have a chance to work. Biofilm, again, Becky's known, it's all the rage at the moment, and so it should be. I'll give some detail on that. And again, supporting Becky, that I think there's probably too many occasions where general products are being used, and I think that there's again a great opportunity for the industry to perhaps have a little bit more dialogue before 25 litres of something or 5 litres of something is purchased, a dialogue between the farm and probably the veterinarian and the people who are selling the products, so that what you spend your money on has a chance of working against the specific bacteria causing problems and costing you money on the farm. And we finish off with time to dry, which again is a bit of a challenge coming from the British Isles, well known for its dryness or lack of at certain times of year. But again, I think the producers need to understand that dryness is really the final part of the cleaning process. The reason being that quite a number of the bacteria and viruses that we deal with are not favoured. So we move it on. So how do we do it? Well, I think again, just putting in the negatives in front first, is that actually if you spend time and money on cleaning and it doesn't work, then it's very expensive. If you choose the wrong product, possibly because there's a wee bargain on the go down the road, that's very expensive. And I think perhaps we need to sort of reconsider a little bit how we assess the financial side of this. because if it's not competent, if the cleaning process isn't competent, that's a waste of poor use of valuable time and money. What are the main reasons that we fall over getting the job right? Lack of relevant knowledge sometimes. I'm a biased scientist, but I think perhaps if we're looking at persistent problems, we probably could get good payback from finding out what are the specific microbes that we're dealing with here, so that, as Becky said, we can perhaps identify the correct product. Lack of time, again, very cruel, but I'll come to that in a minute. Space is something that I'm especially seeing in the cattle industry, but we can see it in the pig industry too, because we get sort of backlogs of animals, or the slow doers loitering down one end of the shed that you're trying to clean. And the broiler industry has learnt the hard way that if you cut down on the turnaround time in a building, it becomes increasingly difficult to get rid of your target organisms. And I think my final general point there would be the lack of cleanable facilities. So in the slide in front of us here, there's a rubble wall. It's probably only about 200 years old. It's probably got 1,000 million wee holes in it, and timber up there. But somebody's had a good go, lime washing the walls, filling in all the holes. But I think especially on the cattle side and some of the older pig facilities, we should be more realistic and objective. Some of our facilities are not cleanable. And therefore, if we spend time and money trying to clean them, and it's never going to work because the timber work is 100 years old and has never been properly cleaned. It's an impossible task, and we really should be more realistic about it. So we come on and we say, right, we need space to be able to clean properly. And we've been told a long time that all in, all out is really that's as good as we're going to get if we do everything else properly, and that's true. The poultry industry does it extremely well. The pig industry does it in places extremely well. The cattle industry is quite a long way behind, and I think we need to be. If you've got a building and it's never empty, we have to question whether we can clean the building competently at all. We also know that there will be a slow build-up of at least background organisms, the commensals, in a building environment, and so over time, the background of commensal organisms and the concentration of them is going to grow, and if nothing else, is going to apply a little bit more pressure on the immune system of the animals in that building. So we need to be able to clean, but if the building is never empty, how are we going to manage that? And so I'm certainly suggesting that in the cattle sector, that one way to look at this is to have a look at your maybe calving index or periods. Basically, you're looking for periods when you have the lowest number of stock in the building. Can you put them outside? It's only going to maybe be for 24, 48 hours in the middle of summer, but to do the job properly, and then the building will be genuinely clean when you put them back in. At this point, one of the issues, we come back to time and money, and people were saying, well, I can't do that. We're running around and we've got silage to make, whatever. But I think that people should perhaps, again, step back and look at the impact of just not only the frontline pathogens that we're trying to eliminate, but the general background of bacteria in a building, and sort of suggest that, well, if we could get 3, 4, 5% increased daily live weight gain through a calf young stock shed or through a grower pig shed, do the maths on that, and maybe you'll work out a way to make it better. We also have an issue in space and time. When we talk about the weather, that for example, this time of year can be incredibly difficult to get a building clean and dry because it's cold and it's damp. We can do it with controlled environment buildings by shoving ventilation rates up. Cattle buildings, that's maybe not the case. And I think perhaps as well that when the temperatures get like they are now towards sub-zero, then we perhaps, in a dialogue with the veterinarians, should look at a cold weather cleaning regime. And certainly on the pig sector and outdoor pigs, If vaccination policies on the sows are up to date, certainly up here in Scotland, we would be advocating there's no point trying to throw water around when the conditions are freezing. Then maybe what we need to do is, as I said, keep the vaccination policies tight on our sows, use dry disinfectant, and make sure there's a lot of clean straw floating about. And use dry sanitizers or slaked lime in the deep straw bed. We must acknowledge the problems of the lack of space and time, but be realistic about how we might manage them better. Moving on, the floor. Floor is an important part of the whole building. Last time I looked, all animals tend to be on the floors and not up in the air. Cleaning a floor is a fundamental part of cleaning a building. And unfortunately, we see a few buildings that, we've got lots of pooling around the place. And again, it's coming back to facilities, if we're objective about it, are very hard to clean. So in the broiler sector, for example, doing work on Salmonella and Campylobacter, these buildings are cleaned professionally to a very high standard. But actually, once the infrastructure, the concrete, the cracks on the floor, where the wall meets the floor, it's much easier after professional cleaning to go and find E. coli in an old building. It's just how it all works. And so, again, I think we need to be a little bit more realistic. And so here we are. Here, I'm looking at the fact that a building here, they could never get rid of scours. And so the producers, I'm saying, will make it more cleanable, make the wall cleanable, put a render on this 100-year-old granite wall, cut a hole in the floor, make it so that when you wash it, you can clean it and dry it effectively, add competent slopes. It seems like a good way of doing it. I think as well, we need to be realistic about the survival of some of the organisms out there. That IVR certainly has been found alive 30 days outside of a host, living in the environment, living in the biofilm, which we'll come on to in a minute. And I think if we're looking at rubble walls or breeze blocks, broken floors, bad drains, rusty fittings, joints that we can't get at, it's a matter of maybe we need to up the intensity with which we clean things properly. What are the solutions? Well, investments in renders and sealants, getting the drains like here in the right place, or perhaps just straight investment. Throw things away and buy new ones. Look at the payback you might get on that. I think calf pens, when you consider the level of hygiene that is present on every dairy farm in terms of around the parlour, I'm not quite sure why we shouldn't target having the same level of hygiene or cleanability in our calf pens and calf environments. These are very young animals with very sort of poor immune systems, or not poor, but developing immune systems. And I'm saying, why not put an industrial, a proper render on the wall, a paint on the wall, what's the payback? Well, the payback should be that once you've cleaned it, there's a lower burden of bacteria. It will make people's time and money spent doing the cleaning process a lot more efficient, and that's where you get the money back. You could also have some nice colours, why don't we have some nice colours floating around? So, what are we doing here? I'm saying we need to be realistic about the cleanability, and we need to be realistic about what we're doing. So we need to remove the organic matter. And again, I think that perhaps the cattle sector could help itself a little bit here. We say we're all busy, but maybe people need to get off the mat, bro, and get out a fork as well and get rid of that last bit of organic matter. Because if you've got a pen, you're going to put young stock in it. If you could take a couple of kilos of organic matter out of there because you've got off the mat, bro, and scraped it out, then from what Becky said that when you actually chuck the disinfectant in, it's going to have a chance of working. That's a very simple thing. But if people don't have the time or aren't given the time because of the system they're running, that's a real weakness that we need to be honest about. Soaking and washing. very much again a time issue. The pig sector, people have found that the investment, so you call it a cost, but actually it's an investment of putting in sprays, hardwired systems, so that you can, as soon as the pigs are out of the room, you can give it a drench of a spray and leave it for a couple of hours so everything starts to soften up. It's absolutely imperative for getting rid of some of these bacteria and viruses that we're dealing with. Again, though, we look at a system. If you start throwing a lot of liquid about and power washing, then you'll create aerosols. Where basically the moisture particles become vectors for the microbes that are in the building. And again, on the chicken and pig sector, there's clear scientific data that you can spread things by the aerosol route. So we need to be careful. And then you look again and say, well, if I have a building that's continually stocked and I clean out 1/4 of it when the other 3/4 are full, it's impossible to do a perfect job. Relevant disinfectant at the correct measured concentration. This comes back to what Becky was saying and the work that they're doing. Work that other people have done. There's a small amount of you using disinfectants in what I would call constructs of realistic farm environments where there's a lot of dirt lying around first, and the reduction in the efficacy of some of these products is amazing. It's really not worth the time of using them at all. So we come back again, we need to get rid of that organic matter, and also to be slightly aware that temperature is an issue as well, that some of these disinfectants, they have optimum, like anything else, they're chemicals, they have optimum range of environmental temperatures that they work at, and being cold or hot increases the efficacy at which they're worked. Contact time, I think possibly we'll see the use of more foams, because that's great, we can see it. It's still on the wall. Read the panel, read the box, and if it says it needs 2 hours contact time to work properly and the system doesn't allow us to do it, we shouldn't expect it to work properly. And then finally we come down to the fact that yes, allow to dry. The tail enders, this is where we see the tail enders again. You've got sort of 8 pens in the building, and the poor doers are down in the pen at the end, and that stops us giving people enough time to clean the building properly. We really need to ask ourselves the question, is that, those half dozen steers or half dozen grower pigs down in that end bay, are we better off leaving them where they are because we think we're helping those 5 or 6 animals, or should we actually get them out of there as best we can into whatever kind of accommodation so we can clean the building properly for the sort of next 60 calves or 300 pigs or whatever they're going to come into the building, and think which ones are going to make us the money? Because the poor doers are probably poor doing because they're shedding virus all over the place. We need to get them out so that people can do their job properly, and also be realistic that by being allowed to dry, there's certain times of the year when that's going to be so difficult, and maybe we should use a bit more slaked lime around the place like people did 50 years ago. Nice messy slide there. Biofilm, Becky's mentioned it. Biofilm is the stuff that you don't see because it's inside pipeworks. It's also the stuff that we see all the time. Easiest way to find it is you take your thumbnail and you rub it up a surface. Don't do it down a surface. Rub it up a surface, and you'll get a little sort of waxy coating on your thumbnail there. From the bottom of feeders, sides of feeders, around the area where you prepare the food, up the side of panels after you've power washed it. That's what biofilm is. We don't have time here to go into what it's all about, but the important thing about the biofilm is that there's quite a few pathogens find it a nice place to live. I mentioned before IBR has been found 30 days outside the host inside cattle feeders, but there's a whole pile of organisms that happily survive inside biofilm. And the problem from the subject we're talking about today in sort of disinfectants, detergents and cleaning is that the biofilm protects quite a number of the relevant pathogens from the activity of these disinfectants, and that's highly vital again, because as a business, you've purchased the product, you've told people how to use it properly, they use it properly, you think the job is done, and then but in fact in the biofilm there you have a certain amount of E. coli or Cryptosporidium or Campylobacter floating around in there. And what's worse is that the biofilm is like a living little world inside, especially pipework. And as we put more water through a pipe, or even put some nutrients through pipework for pigs or poultry, the biofilm will grow. And then what happens is that every so often it will slough particles, and that's you drip feeding a nice little mixture of nutrients and bacteria straight into the mouth of your pig. So we're looking there for the fact that drinkers and water pipes is a place we need to pay more attention, and our climate again, which is quite often quite cold, is we have a number of pathogens that like our climate for living that. What's the solution? Well, again, the poultry industry is pretty good at this. The pig industry is slowly waking up to it. The cattle industry, plenty to do there. A deep clean. And certainly I'm punting the idea that, whilst we have routine cleaning, we should have deep cleans in one or two situations, either as a planned annual clean to reduce the steady accumulation of background pathogens, or secondly, after an acute outbreak of an infection in an area of a building or a series of pens. What is a deep clean? Well, it's the same as before. You get rid of the organic matter as best you can. Right product, right time. But it will include also a steam clean followed by a detergent. Now, both of those are really targeting biofilm. And so we know, and also obviously steam cleaning will in itself, by raising temperature, increase the kill rates of various microbes. So steam cleaning, 60 degrees, is clearly beneficial. Will remove more of the biofilm and its waxy nature, and the detergent will do the same thing. It's like trying to wash a saucepan in a stream of cold water. It's extremely difficult, but you put in a bit of detergent and you'll make it a lot better. We need specific aggressive disinfectants, and again, we're looking to let things dry properly. So people say to us, it's hard to kill Cryptosporidium. Yes, it is hard to kill Cryptosporidium if you don't know how to kill it. As soon as you know how to kill it, and this is work from Morden, where we can all read, but they've highlighted 4 products there, and a bit like Becky has been talking about, specific products with specific activities for a certain amount of time. And if we let people do their job properly and tell them what to use, then Cryptosporidium, either within cleanables facilities, we can nail them, and we should well be able to nail them. I do reiterate, though, but if we're looking at Cryptosporidium in calf housing, if it's got breeze block walls that haven't been deep cleaned or power washed for the last 30 years, don't be able to expect 3% hydrogen peroxide to be able to kill everything, because we're not supplying an environment which is actually cleanable. The water systems I mentioned, I think very good potential here to lift general background animal health. We need to be realistic. How are we going to do anything about it? Well, the best way to go about it is it's such an important ingredient of health and productivity. We need to consider how organic matter is probably already lying within the water systems. You start rumbling these things up, and there's nothing else. There's going to be a whole pile of organic matter, and crap's going to come out of the nipple drinkers or the water bowls or in front of the dry cows. And what we really need to do is measure the quality of the water that's in that system. Do we have much of a problem? If we don't, we can probably leave it all alone. but we must be aware that when we start to sort of dislodge this type of material, which we have to, because of course a disinfectant isn't going to touch that, it's going to be gobbled up by all the organic matter in the system. So we need a deep clean, and we need to, once we've had an annual test of water quality, we need to purge the system to remove the organic debris. If the thing hasn't been touched for 30 years, I suggest you take some spares with you and a wetsuit, because you're going to get in such a mess. But the benefits are that you're then going to know that you'll be able to deliver clean water to the livestock, and take it from there, and thereafter to use a protocol or whatever you like, with information from people in the sector, to use water sanitizers to remove the biofilm and bacteria and keep the thing clean. Once you've been through the cleaning process, I'm repeating myself now, check flow rates at the drinkers. And if you're using boreholes, which many farmers are doing, perhaps if you have inline filters to remove organic matter in the supply side, that needs to have a routine check as well. But there's tremendous potential to improve on all of this. We're seeing, it's in the cattle sector, that the idea that we have water systems, water troughs that can be turned over. Well, here's somebody doing it for young stock too. And I think there's a lot that we can be gained. But again, the important point here is that they are cleanable. Getting 40 gallons of cold, dirty water out of a concrete trough with no holes in the side, no drain, is a pretty impossible task. So I think it's straightforward, but I'm just suggesting that what we need to be a bit more ruthless and a bit more objective. Do we actually have the necessary resources to do the cleaning? Are we asking too much of these? You've tried and tested products, because the things aren't cleanable. That calf bucket is actually only 45 years old, and to look for payback on investment, because the chronic losses from background poor levels of hygiene are really quite high. Certainly I know of work from Australia whereby 11% decrease in daily live weight gain in growing pigs, purely by the amount of debris in the air of commensals, not even pathogens. But as you move forward, you have a realistic cleaning protocol, right products, right amount of time, and train people to use it, so that they know how much needs to go into a bucket as opposed to just a slosh. So I'll leave it there. Time, space makes things cleanable. Right disinfectant, right dilution, and time to dry. So I'll leave it there. Thank you very much.